Good afternoon, everyone. This is the post-mission press conference for the Falcon 9 COTS-1 mission. And here to discuss today's launch and on-orbit mission and splashdown is Alan Lindenmoyer, the manager from the Commercial Crew and Cargo Program Office at the Johnson Space Center in Houston. Elon Musk, the Chief Executive Officer and Chief Technology Officer from SpaceX, coming to us from Hawthorne, California, the SpaceX Mission Control Center. And Gwen Shotwell, the president of SpaceX from Hawthorne, California. And we'll begin first with Alan Lindenmoyer from the COTS Program Office in Houston.
Thank you. Thank you, George. What a great day for SpaceX. What a great day for NASA, and what a historic day for commercial space flight. You know, we were here Monday, and Phil talked a lot about emphasizing how this was a test flight, and that our experience is we should expect anomalies. And I came here today prepared to talk about, you know, all the things we learn about when we have problems, and then we find our way forward. Well, I'm afraid I don't have to give that speech today, so I'm very happy not to be able to talk about that. As a matter of fact, Gwen and I spent the day in the Launch Control Center, and we were looking at our objectives, and there was a long list of these objectives we had laid out for this flight, and of course we didn't expect to have them all met, but as the day went along, we ended up checking off all of the mission objectives for this demonstration flight. So it was, from all indications, looks like it was 100% successful, and it was just a great experience and wonderful to watch. And it is quite an achievement. I was looking over some of the information that I was going to present to you in the case that there was a problem. And the fact is, over the last 20 years, for new launch vehicles, only about 50% of them are successful on the first or second flight. And then actually only 1 out of 3 of them have 2 successful flights in a row. So this is really an amazing accomplishment for SpaceX. And I guess the other thing we observed and witnessed is the skill that SpaceX demonstrated in identifying the root cause of the problem that was discovered on Monday, and the skill for even looking for the problem, actually, and finding it before they had the launch is also something to be commended. But so quickly turning it around, finding the root cause, and then the agility to actually implement the repair, get ready for flight, and turn around quicker than it was originally planned is a great demonstration of SpaceX skill and agility. I talked about Monday this being an experiment of a new way of doing business with NASA and the private industry, and I would say today this is an indication that this experiment is working. This public-private partnership is certainly shown to be successful today with the successful launch of the station. So congratulations to SpaceX on excellent work. We're certainly looking forward to our next demonstration flight and taking the next step closer to the International Space Station. Thank you for the early Christmas present, and what a great way to start the holidays. And I know you guys deserve a break, and we'll be able to enjoy it now. So thank you very much.
All right, thank you, Alan. And we'll go out to SpaceX Mission Control in Hawthorne, California, to Elon Musk, the CEO and Chief Technology Officer for SpaceX. Elon?
Thank you. Yeah, this has really been better than I expected. I'm just looking at all the mission data, both real time and what's come back from some of the stored telemetry, and it's actually almost too good. I mean, we have many. I shouldn't seem surprised by that, but there are many redundant systems on Dragon. For instance, it's got 18 engines. All 18 worked flawlessly. It's got redundant parachutes, and we could land with one main parachute in the water and still be okay, and all three worked. Our angle of attack was spot on at 12 degrees. We thought there may be as much as a 20% dispersion on that, but it was 2% dispersion. So I think it's just a testament to the incredible work of the people at SpaceX. I mean, everyone just did their job so well. I mean, for a rocket to work and then a spacecraft to work, they're both incredibly complex devices. There's so much that can go wrong, and it all went right. We didn't even have to go to any backup systems or anything at any point. Yeah, so just I'm sort of in semi-shock. I wish I could be more articulate at moments like this, but I think there's just sort of a natural reaction which kind of blows my mind. So it's hard to be articulate with a blown mind. I want to really thank NASA and the COTS team at NASA, particularly Alan, Fallon, Mike. We wouldn't be here without the help of people might think, whoa, this is sort of like SpaceX being so great, but we would not be here without the help of NASA, and that I cannot emphasize that enough. So and then of course the work that SpaceX has done with our craft, with Dragon and Falcon 9. The core technologies again were developed by NASA over decades, and we've built upon them. But I guess to use a phrase that's been used many times before, we're only here because we stand on the shoulders of giants. As Alan said, I think this is really just a great example of a public-private partnership. I think there should be certainly more of that within NASA, but actually even throughout the federal government. I think this is the whole COTS model is a really good model, and also executed really well. I think it's so. Thanks, guys. I mean, thank you. Obviously on the space station operations side, it's just like there's so many people I could thank, but I just want to be clear. It's like, without NASA, we wouldn't be here. So thank you.
All right, thank you, Elon. And now to Gwen Shotwell.
Actually, I've got more to say, if I may. But I did want to be very emphatic on that point. I think a few key things worth noting about this flight, which you may have heard already, but are worth noting. The restart of the second stage went perfectly. The second stage went up to 11,000 kilometers. And that's with the shorties good. So, with the trimmed nozzle. So I think it shows, so we're able to, that was certainly not part of the primary objective. It was sort of a nice to have. But that second stage is currently proceeding in an orbit with an apogee of 11,000 kilometers. What other cool things? The other things, people sometimes think that the difference between, to take a cargo spacecraft and put crew in it requires this enormous amount of magical pixie dust or something. This is not at all the case. If there'd been people sitting in the Dragon capsule today, they would have had a very nice ride. And they would have experienced, maybe up to 4.5 Gs, about what you'd see at an amusement park, and they would have done quite well. So it's except for the escape system, and its seats and some minor upgrades to the life support system, the vehicle that you saw today that can easily transport people. We do agree with the need to have a launch escape system, and the testing of launch escape system is a difficult thing, and then I should also say that although for the architecture that you observed today is obviously similar to what was employed in the Apollo era, but the next generation Dragon, the Crew Dragon, we're actually going to be aiming for a propulsive landing with gear, kind of like Eagle landed on the moon. And we'll still have the parachute as a backup, but it's going to be a precision landing. You can literally land on a helipad, on something the size of a helipad, propulsively with gear, refuel, and take off again. That'll be the next generation Dragon. It was important for us to test the fundamentals with an ocean landing to make sure we could control things to a precision location, and to test the heat shield and the fundamentals. You've got to make sure that if something does go wrong, that nothing bad's going to happen. But I want to be clear that we are definitely going to be pushing the technology envelope beyond what you've seen here. And then people have also heard me say this before, but full reusability of the Falcon 9 is important as well. And that's something we're definitely going to figure out over time. Let's see. Oh, I should say the performance of the heat shield was spectacular. It barely noticed the reentry, and in an excess of caution, we actually designed the heat shield to not just handle Earth orbit reentry, but to actually be able to handle a worst case off-nominal lunar reentry and Mars reentry. So it's an extremely capable heat shield. The Pico was originally developed at NASA Ames, and then we worked with NASA Ames to develop an improvement on Pico called Pico X, and with this reentry, we were able to calibrate the effectiveness of the heat shield, and I'd say I'm highly confident, in fact, definitive, that the heat shield could take lunar and even a Mars reentry, which opens up a lot of possibilities, I think. As potentially an alternative to the Orion.
Okay, thank you, Elon. Let's go now to Gwen Shotwell, who's the president of SpaceX from Hawthorne, California. And Gwen, your comments on today's launch and mission.
Thank you. I wanted to do a brief recap of the mission and then talk about some of the details on orbit. We did lift off at 10:43 Eastern Standard Time. We followed the nominal mission profile. We had first stage shutdown on time. Stage separation was nominal. Second stage engine start. Nose cone jettison at about 3 minutes and 37 seconds into the mission. Second stage cutoff, nominal as well. Nominal separation of the Dragon spacecraft. And then we had our on-orbit operations, and you guys had some questions about what that meant on Monday. We did maintain attitude control, thermal control. Our comms program worked brilliantly. We had connectivity with the Cape ground station, Wallops ground station, Australia ground station in Australia, and Bermuda as well. I believe Bermuda. No, not Bermuda, sorry. We also had full TDRS coverage, both omni and directional. And the directional TDRS required pretty specific pointing of Dragon in order to maintain that link. And we achieved that, we maintained it, and it really worked flawlessly. We began the deorbit burn at 2 2 hours and 32 minutes into the mission. We finished that deorbit burn slightly early. The reentry phase began at 2 hours and 58 minutes into the mission. Our drogue chutes deployed nominally. 3 mains deployed nominally as well. By the way, we achieved an 8 meter per second descent speed, which is, as Elon mentioned, quite comfortable from a landing perspective. We believed we projected we would have our water landing at 3 hours and 19 minutes into the mission. We actually did it in 3 hours, 19 minutes, and 52 seconds, which was awesome. I've got some very preliminary data on the landing. I had heard in the control center that we landed within 10 kilometers of the landing point. I saw communication from our team to the Air Force, said we were within 800 meters. I'll confirm that, but that was awfully nice to see. Our landing ellipse was 60 by 20 kilometers, and we were well inside of that. So all around, I wanted to thank the 1,200 men and women at SpaceX who helped achieve this really extraordinary mission. NASA, of course, Elon spent some time with that, and I'll let that go. Also thank our other mission partners. The Air Force 45th Space Wing was enormously helpful for this mission. Helped a pretty quick recycle, as you guys were aware, and then the FAA for the licensing effort that we had. I promised you on Monday that I would try to get some photos of the skirt, and I got those cleared this morning. So can we show the photos of the skirt? That's one of the cracks. By the way, they were about this big. And the next photo, the other crack. I think we put out a release as to root cause on that. Finding the root cause as early as we did allow us to fly a day earlier than we anticipated, which is awesome. It's nice to beat your target instead of miss it. I want to show another photo. The gentleman who actually repaired that's Marty Anderson, awesome tech from SpaceX. He flew out here on Tuesday morning and repaired the skirt. You could see the beautiful job. That was a hand cut that he did on that skirt. Next photo. And there's the repair right there. So that was really brilliantly executed. Just so you know, we did execute that rapidly. There were no corners cut. We did full fishbone diagrams, full fault, try to find where the fault was, what was the root cause of that. We did find it, we verified it, and we analyzed for the repair that we wanted to make, full analysis, provided the analysis to NASA. And we were ready to fly this morning. So it's really an extraordinary effort, both with the SpaceX folks, NASA, and the Air Force for chipping in there. Yeah, I think that concludes. I think we're all ready for questions.
I think,
the Dragon pictures? Yeah, okay,
Yeah,
we've got two
yes.
recovery photos of Dragon.
And we may have a launch picture as well. We're going to run through those pictures right now.
Okay, so we got some launch photos and then some recovery photos. Let's lift off. Some on-orbit photos from Dragon. And there's Dragon with the recovery boat nearby. So really extraordinary. Those came in from my cell phone, or on my cell phone, and I forwarded them to NASA like right before we came over here. So technology worked really well today.
All right, thank you, Gwen. We're ready now to take questions. Please give your name and affiliation when the microphone comes to you. And we'll start here in the front with Marcia.
Marcia Dunn, Associated Press for Mr. Musk. I'm wondering, what was that moment like for you when you heard about the 3 parachutes being deployed? And do you think that your success today will finally quiet your detractors regarding commercial crew efforts?
It was definitely a moment of elation and great relief. There's really the drogue deploy and main chute deploy were the riskiest points in the mission. So when those main chutes came out, it was a done deal. yeah, and it's just mind-blowingly awesome. So again, you know, I apologize, and I wish I was more, excuse me, more articulate. But it's hard to be articulate when your mind's blown, but in a very good way. As far as will it quiet out attractors? Well, you know, I think if there really are people who are going to sort of still find a way to cast aspersions on what was done today, then you know I pity them. It's because they're just that wouldn't make any sense. They'll be fighting on the wrong side of yesterday's war. So, but you know, there's a lot of people in the world, and there will be still some who are negative, but I suspect far fewer. You know, of course, some level of skepticism was entirely warranted for what we're doing because it is very difficult. If you consider the class of vehicle that was both, you know, the lifter and the Falcon 9 and Dragon, previously these have really just been done by the Soviet Union. I mean, actually, I say Soviet Union, not Russia, because Russia has not developed new things since the Soviet Union. China and the United States, and that's it. And with sort of their collective industries behind them. This was done with 1,200 people, and we're vertically integrated as well. So it's not as though there's a huge amount that's, I mean, we make the engines, the structure, the avionics, and conduct the launch operation. Although I should point out, it's not because of some dogmatic fixation on being vertically integrated. It's simply that the space supply chain is very shallow, very often there's only one supplier of a component, and it's very expensive. So if you don't if you don't become vertically integrated, then you can't change the equation on space. It stands to reason that to the degree you use legacy components, you inherit the legacy cost structure. And I think this is a very important point to bear in mind. I know there's sort of a lot of impetus or feeling in some quarters to reuse a lot of the shuttle components. But again, I'd say to the degree that you use legacy components, you inherit the legacy cost structure. And that just needs to be considered.
Okay, Bill?
Bill Horowitz, CBS News, with two questions, and I'm not sure if it's for Gwen or for Elon, either one. Can one of you maybe give us a better sense of what sort of orbital operations you did? I mean, I know you were doing maneuvers. Were these mimicking, you know, space station rendezvous sorts of maneuvers, or was it just basic exercise of the thrusters? And I was curious how the guidance, navigation, control went. Gwen, you said you had good luck with Tidra, so obviously it worked well, but any additional detail would be great. And my second question was for Elon, probably. Given the success of this flight, can you give us any update on the schedule going ahead with the two remaining COTS demo flights? Thanks.
Sure. So, yeah, the maneuvers that were conducted were very similar to the sort of maneuvers that we would conduct in going to the space station and berthing with the space station. There's really, I would say, there's no meaningful difference in complexity between the maneuvers that were conducted today and what will be conducted in going to the space station. All the thrusters worked just exactly as expected. And like I said, we've got 18 thrusters, but really, you could, if 6 of them failed, well, it depends on which 6, but any 2 thrusters can fail, and we still have full authority to translate and rotate in any direction. I think I feel very confident in being able to conduct the proximity operations and berthing operation with the space station with the next flight. You know, in our discussions with NASA said that if this flight goes well, then they would strongly consider allowing us to go directly to the space station on the next mission. And I'm hopeful that that's what NASA will allow us to do. And of course, we need to carefully examine the data from this mission and make sure that it's all good and everything. But I'm optimistic that the next flight will be to the space station. It's there are some additional elements that need to be added to Dragon for the space station mission, such as the solar panels and some improvements in redundancy in the flight computer, mostly in the electronics area. But I feel highly confident that we can make it to station on the next flight, and that we can do so by approximately the middle of next year. Probably summer next year is a rough guess. I'd say that's if things go reasonably well from here. There won't really be any changes to the structure or the engines. A lot of the telemetry remains largely the same. So it's really a relatively small delta between what this vehicle and the one that would go to the station. So that's why I feel really confident in being able to get there.
Okay, Bobby?
Bobby Block for the Orlando Sentinel. Elon, two questions. First, were you able to recover the first stage? And then the second question.
Oh, Bobby. Must you ask that question? All right, fair enough.
And the second question is, not long ago, the Deficit Reduction Committee was talking about maybe a good idea to lower the deficit by not funding commercial spaceflight. And given that everyone here is talking about what a great public-private partnership that was, I was wondering if you thought the success of today's mission was another reason to rethink that.
The recovery of we were not able to recover the first stage of Falcon 9, but I want to be clear that was never a mission. That was a nice to have, sort of a little icing on the cake from a SpaceX standpoint, but completely unrelated to any of the space station servicing missions or anything like that. A good thing I can say though is that we were able to get a lot more data on the reentry of the first stage, which gives us. We were able to get a little further down, a little closer to Earth, and a lot of data. And we actually, this time around, built a little specialized black box, like they have on aircraft, that collected telemetry, video, and so forth, so we can actually try to figure out where do we need to improve the thermal shielding, where do we need to improve things structurally, and that is going to give us a much better shot at recovering future first stages. So we're sort of incrementally getting closer and closer to recovering the first stage. No one's ever recovered a liquid first stage intact. So it's a very difficult thing to do because you can't just apply huge amounts of thermal shielding and massively buff it up, because then you'll lose so much payload to orbit that you won't be able to fly. So it has to be a very carefully sculpted armor, if you will, and even a tiny chink in the armor is enough to take it out. But we're gradually covering all the chinks in the armor, optimizing it all. So I do feel very confident of being able to recover that first stage. I'd say I'd be very disappointed if we haven't recovered a first stage intact in, let's say, 2 to 3 years, intact to the degree that can be flown again. Of course, we need to either find a customer that's willing to fly that stage or fly it ourselves to prove it out. But I do feel very, very strongly about reusability. I think it's incredibly fundamental. It's the holy grail of orbital spaceflight. And it's incredibly difficult. I mean, it's just that's why it hasn't been done. And there's some out there who'd say it's impossible, and that's a truly reusable orbit class rocket is the fundamental breakthrough, the fundamental invention necessary for humanity to expand beyond Earth. In the absence of that, we will be confined to Earth forever, apart from perhaps the occasional flags and footprints mission. Just as if Columbus's ships had not been reusable, there would be no America. Yeah.
Okay, Irene?
So sorry, I'm not sure. I mean, there was another, the deficit question, or reduction question. Well, I think the recommendation to cut commercial crew was ultimately not in the final published report. So they got rid of that when they realized that they were completely wrong. Cutting commercial crew would not decrease the deficit; it would increase the deficit, and it would also mean that there would be no American access to space. So yeah, any politician who wishes to increase the deficit and not have American access to space, go ahead and cut. But I think they were just misled. I don't know by whom, but I think they were just unfortunately were given bad information, which they then eventually realized was bad information, which is why it didn't make it into the final report.
Irene Klotz with Reuters and Aviation Week. The first question is, there was the photographers had in their images a flame flare during launch. Can someone just discuss what that was?
Yeah, there was just the second stage umbilical. There was just there's a check. This is speculation, so it's always tricky until we've gone in there and done sort of full forensics and stuff to say definitively what it was. Because I suspect what occurred there was that a check valve on the or some checking fixture on the second stage umbilical on the ground side didn't check properly, so it just caught fire when the engines passed by. I mean, it's not really an explosion. It's actually just a little fire.
Thank you. And in your opening comments, Elon, you made reference about the commercial crew, and obviously there's a competition underway. I assume SpaceX is putting in a bid for the CC-DEV program. But if for some reason you were not selected to have your technology funded under a NASA program, what's your go-forward plan? And does this launch, I mean, has Bob Bigelow called you up yet today to rethink his relationship with Boeing or anything? Or where do you think your company will be moving forward? Thanks.
Well, it's difficult to predict. I don't want to be presumptive. Speaking for my opinion, my assessment is that SpaceX would be the most rapid path to an American crew transport system. As I mentioned in my opening remarks, if we'd had people on this flight, we would have taken them to orbit and returned them to Earth safely. And so it's really going to a crew system is just about adding some additional safety systems for highly off-nominal situations like the escape engines and some upgrades to the life support system, which are relatively minor. But even on our cargo missions, we will be carrying plants and animals. It's there and back up to the space station and back. So I think it's I think we're in a very strong position to be one of the winners of the commercial crew carriage, and there'll be others. Maybe I don't know how many, two or three. And I do think I think competition is good. By the way, I think it's a good. You don't want to have everything be too dependent on one company. So there'll likely be at least 2, maybe 3 commercial crew providers. Hopefully, we're one of them. So.
Okay, Todd?
Todd Halverson, Florida Today and USA Today for Alan Lindenmoyer. I was wondering what you thought of the idea of combining the objectives of COTS-2 and COTS-3 and whether that would be an acceptable go-forward plan for NASA.
Well, certainly after today, we have increased confidence in SpaceX systems and the launch vehicles and the spacecraft and the Dragon that was demonstrated. We have very specific objectives laid out for the next mission, and then as well as the third mission. And it was always planned to be incremental in increasing in complexity. So I would say we will consider the proposals that SpaceX provides. We will assess the possibility and the feasibility and making sure it's technically possible with the equipment that's planned to be available in that time frame. And we'll certainly give it a good consideration.
Hi, Robert Perlman with CollectSpace.com with a couple of questions for Elon. You spoke about reusability, and along those lines, I wonder what your best hope for this particular Dragon capsule is. Do you want to fly it again? Do you want to see it in the Smithsonian? Do you want to put it in your office? What's the fate for it?
You can make it in my office. Welcome to my office. I haven't really thought about that. The first thing we're going to do, obviously, is examine the spacecraft very, very closely. We're going to do deep forensics on it to see, did anything break? Is there any place that we should be perhaps strengthening? There are actually definitely places I know where we've got, say, too much material because we weren't sure, so we just added a lot of margin. The thermal protection on the leeward side of the back shell, which had a reentry temperature that was basically room temperature, clearly doesn't need two inches of thermal protection. So there's definitely places where we can trim mass out of the system and still have enormous safety margins. So this is really going to be here at the factory, being thoroughly taken apart and examined to learn as much as possible. Where it goes from there, I'm not sure. Certainly, it would be a great honor to have anything in the Smithsonian. That's my, Smithsonian Air and Space Museum, my favorite museum in the world. It's super great. I can just sit in there for hours, just staring at all the cool things in there. So.
Okay, James.
Hi, James Dean from Florida today. For Elon, the nozzle repair seems a bit of an afterthought now, but it seemed kind of amazing that you could just go in and lop off a piece of your nozzle. And, fair or not, there seemed to be a perception that if this was a NASA mission, it would have been studied and analyzed for days and weeks. And I wondered if you could just comment on whether that episode, as much as the flight itself, kind of reflects how you as a company operate differently.
We're certainly very, I think, agile. I mean, we're a smallish company, so we can be very agile, and we know that engine so well, and how it's built, and what matters and what doesn't matter. I mean, in fact, we didn't really need to trim we could have flown it with the cracks, and it would probably have been fine. In fact, I'd say 95% likely to be fine even with the cracks, because the stresses in that part of the nozzle are so low, it wouldn't even grow the cracks. So it was really out of nexus of caution that we trimmed the nozzle. We've got some phenomenal technicians that are just incredibly skilled artists almost, and Marty's one of our best. And if Marty does something, you can count on it. He's a great guy. By the way, he has a huge fear of flying. So it was. It took an enormous amount of will for him to actually just get on a plane, and he won't fly for anything. But he got on a plane for this. Good man. I mean, I think it may help that I'm both the CEO and the chief designer. So sometimes if the chief designer and the CEO are not the same person, then it's hard to make a decision. it's much harder to make a decision in that situation. But I know that the nozzle will be fine. I know it will be fine. So therefore, I don't have any compunction about cutting a piece of it off. And we did, even though it was sort of intuitively obvious to us that it would work, we still reran all the simulations, redid all of the analysis, and we're able to do that concurrently with trimming the skirt, so that by the time the skirt was trimmed, we had already completed all of the analyses to prove what we intuitively thought would be true. And then we went over that with NASA, and they were supportive of that, and I actually had a good email dialogue with Bill Gerstenmaier as well, who's very strong technically, and so it was good. I think I don't know, just that's kind of how we do things, and it worked out well.
Okay, James.
Thanks, and I wondered quickly if you or Gwen could just recap where you stand with your hardware for the upcoming flights, and if you do have to fly 2 more, what would the likely timing be? Could you still fly your first CRS mission late next year if you have to fly 2 more demos?
There's a certain. Well, I think from a production rate, we could probably manage to do the COTS-2, 3, and CRS-1 next year, fly them all. But I think there's value in being able to focus as much as possible on one thing. And if we do COTS-2 and COTS-3, we do have to divide our forces to some degree. Because they have to be built sort of semi-simultaneously, and there would be a different configuration. So my view is that it's really the least schedule risk. In my view, is to try to go directly to station, which is, HTV and ATV did that in one flight, and I think there's a bunch of additional ground simulation that we can do around the proximity operations and berthing that can mitigate some of that risk as well, which we would certainly do if we don't fly COTS-2. But I wouldn't get to whether it's COTS-2, COTS-3. It's the key takeaway today is it's going to happen. It's not an if, it's a when. And there's not that much uncertainty around the when. It's at most several months of uncertainty. It's measured in months, certainly not years.
Okay, right here.
Hi, Denise Chow with space.com with a question for Mr. Musk and Ms. Shotwell, if I may. This test flight is considered to be a pretty big significant for the commercial spaceflight industry, and I was just wondering if both of you could characterize how you think it really shapes the landscape and really helps to foster the growth of the private spaceflight industry.
Boss gets to go first.
Okay. Well, I think Alan said this as well. I think it really vindicates this model. This public-private partnership model, and shows that taking the commercial approach to spaceflight, works just as well in spaceflight as it does in air flight, or in other arenas. I think one of the best analogies for the COTS program is actually the airmail program back in the day. That was a huge boost. It really got the American aviation industry going when the post office, instead of doing its own planes, said, "Look, we just got a job to do. We've got to get things from one place to another. Let's put it out to bid." and it resulted in just an explosion of innovation and big improvements in technology and operational capability. And I think that was really the dawn of the aviation, aviation in America, where aviation went from being like this thing that you might do a little joyride on, or only a very rich person could do, to today, where aviation is accessible to almost everyone. I think the COTS program historically will be seen in a similar light.
I just want to make just one quick remark. I think we're beyond now. After today, we're beyond the if, is it possible? And the answer is, of course, it's possible. We did it, and now we can move forward, get some stuff done.
Okay, was there another question over here or no? Okay, we'll take a couple of follow-ups and then wrap it up. Let's go right here.
Hi, Elon. I was reading Spaceflight Now, and I think you mentioned there that if this flight was a success, you would reveal what the secret humorous payload was that was on board. I think we could say this flight was a success. So what was it?
I'm going to leave that for the next news cycle because I'm concerned about what some editors may choose as their headline if I tell it now. But I will reveal it tomorrow.
All right, one more question from Bob.
I think it's kind of funny, and it's like if you like Monty Python, you'll love The Secret.
Elon, Bobby again. You were talking about actually using the possibility of replacing Orion and I think Orion cost so far $4.8 billion. I think in the last press conference after the first Falcon 9 flight, you were talking about $400 million more or less in the development of Falcon 9. Could you talk about how much the development of Dragon cost in comparison to what we were talking about before? And last but not least, I understand you did have a secondary payload that was some nanosats. And did the inclusion of these other customers for these satellites help reduce your costs for this flight?
I don't know if we got paid for that or not. Gwen may have a better answer. Did we?
A tiny bit on one of them.
Much. Yeah, it was like very, very small amounts of money, like not really material numbers. But I do think there's a very interesting road to carry satellites on the second stage of Falcon 9, and then after we've dropped Dragon off in the parking orbit, then restart the Falcon 9 second stage to drop off a whole bunch of smaller satellites. I think that could be a really great way to go. And in fact, I think we probably will do that. And then that certainly could help improve costs. The small satellite market doesn't have a lot of money, so it's really would be more about helping the small satellite market than anything else. Anything, generally speaking, if SpaceX can do something to help further the cause of space or get the public excited about space and make it an inspiring and exciting thing, we want to do that, even if it doesn't make us a lot of money. I think a lot of people have heard me say this before, but the reason I'm doing SpaceX is not because I think this is the rocket business is the easiest place to make money. It's an extraordinarily difficult place to make money. And would be pretty low on the list of things you'd want to try if maximizing your wealth was your goal. But I just happen to have a very strong passion for space, and I really want us to become a true space-rank civilization and ultimately be on a path to becoming a multi-planetary civilization and going out there and exploring the stars and making true the things that one sees in sci-fi movies and reads in books about the future. That's what SpaceX is. That's my goal for SpaceX. And other companies have sort of their corporate goals of profitability and that sort of thing, and which is fine. That's how the economy works. Don't make any value judgments about that. But for SpaceX, it is really about furthering the cause of space. I only care about the fact that we must bring in more money than we spend, otherwise we will go out of business. But maximizing profitability is absolutely not something I care about. And I've told, by the way, we have venture investors in SpaceX, and I told them that. So it's like, you should bear in mind, if you're investing, this is what I'm going to do. So don't complain later that I'm not maximizing profitability. And I do retain a controlling interest in SpaceX, so I can make sure that that happens. And, but we do have a great group of investors, and I think they feel that even if we do a bunch of things that cost us money instead of making us money, that on net we'll still create a very valuable company. So yeah.
Right.
Sorry, I couldn't hear you.
And the question about the cost of developing Orion. I'm sorry, Dragon.
Oh, right, sorry, Orion, yeah, of course. It does seem like a rather large amount of money to create a capsule. I think it's possible to, obviously, look, I'm not sure if people realize this, but Dragon has arguably more capability than Orion. The heat shield is more capable. It has about the same pressurized volume. And so basically, anything Orion can do, Dragon can do. And actually, some things that Dragon can do, Orion can't do. I don't believe the Orion heat shield is capable of re-entering from Mars velocity, whereas ours is designed to do just that. What I'm hopeful for is that NASA may consider the Dragon as I wouldn't say it's like it's good to have multiple companies doing things. So the Lockheed has their Orion, and SpaceX has Dragon, and I think when NASA's considering missions, we'd certainly like Dragon to be considered for any such missions, and I'm confident we can prove that anything that Orion could do, that Dragon can do. And like I said, I think we could actually probably do more because our heat shield is significantly more advanced than what they're using.
All right, thank you, Elon. And we'll have some closing comments now from Alan Lindenmoyer from the COTS Program Office at JSC. Alan?
Thank you, George. I just wanted to acknowledge some folks on my team. We have a very small team that's been working together since the beginning of the COTS program. So our project executive working closely day to day with SpaceX is Mike Horkachuk, and he's assisted by Warren Rumley, and they've done a really great job over the years working on this partnership, along with Valen Thorne, the deputy of the program, and then our colleagues at headquarters, Mark Tim and others, have certainly provided excellent support to help keep the program successful. I'd like to acknowledge our partnership with the FAA. They work very closely with us on and help us review all of the milestones in the COTS program. And I have to say, this experience this week was quite incredible. We participated directly in all the management meetings of the repair work and the decision to fly the truncated nozzle. And my team and I kept firing questions at SpaceX. Very detailed technical questions about the dynamics and the loads and the stresses and the thermal and the verification and the quality control and everything that we're accustomed to doing. And SpaceX consistently came back with full and comprehensive answers, which led us to confidence in supporting the launch today. So, as much as this partnership is learning from NASA, I think there are things we could learn from SpaceX. Certainly proud to be a part of this historic day. It was a very great day for commercial space flight, so congratulations.
Thanks, Alan.
All right, thank you, Alan. And that's going to conclude this briefing for the Falcon 9 and COTS-1, and we'll be looking forward to COTS-2. Thank you very much.